Welcome to Module 6, the forces of demand and supply. In segment 1, we will discuss the market equilibrium. You already learned what determines supply and demand. The most important determinant for both is the price. But what determines the price? This is a main question for this segment. When we try to answer this question, you will also learn what is a market equilibrium? What is the equilibrium price? What is the equilibrium quantity? And how does the adaptation process works? The adaptation process, by the way, is sometimes also called the invisible hand. As already mentioned, the aim of this segment is to find out what determines the price. The price is determined by demand and supply together, by the market forces, by the invisible hand. You probably know the one or the other of the three topics already. They all mean basically the same. In competitive markets, a dynamic process involving demand and supply will make sure that the price in the market is clearly defined. Because the price determines supply and demand, these variables are also clearly defined after the dynamic process sets what we will call later the equilibrium price. In what follows, you will see how this process works in detail. We start with the market demand schedule and the market supply schedule. The demand schedule assigns a quantity demanded to each price. You can see that according to the law of demand, the quantity of demand decreases when the price increases. For example, if the price is 0, the quantity demanded would be 50. If the price increases to 50 cents, the quantity demanded decreases to 20. If the price increases further, the quantity demanded will decrease further. The supply schedule assigns a quantity supplied to each price. You can see that according to the law of supply, the quantity supplied increases when the price increases. So, for example, if the price is 0, none of the producers wants to produce, therefore the quantity is 0. If the price increases to 50 cents, the quantity supplied increases to 2. If the price increases further to 1, 1.5 and so on, you can see that the quantity supplied will increase further. Now we pick randomly, and I admit it's not that randomly, a price. I pick a price of 2 here. So let us assume for whatever reason, and we have to say for whatever reason because we still don't know what determines the price, so let us assume for whatever reason the price would be 2. If the price is 2, then the demanded quantity would be 10. And the supplied quantity would be 10 too. Therefore, the demanded quantity and the supplied quantity match exactly. Whatever is produced is exactly what the market wants. Therefore, there is no reason that the price would change. The price would stay as it is. And we have a name for this price. The price which generates the same quantity demanded than quantity supplied is called the equilibrium price. And the quantity triggered by this price, the quantity demanded and the quantity supplied, are called the equilibrium quantity. We don't have to say if it is the demanded or supplied quantity, because if we have an equilibrium price, the demanded quantity and the supplied quantity are equal by definition. Because the definitions of equilibrium price and equilibrium quantity are extremely important in what follows, here are the definitions in writing again. The equilibrium price is where the demanded quantity is the same as the supplied quantity. The equilibrium quantity is the demanded and supplied quantity which are resulting from the equilibrium price. Don't forget, by definition, they always match. Do you remember that the equilibrium price is $2 in this example? You also can see it because at a price of 2, the demanded quantity as well as the supplied quantity is 10. We want to answer the following question here. Is there a force or an invisible hand which always pushes the price towards the equilibrium price? To examine this question, let us assume the price is higher than the equilibrium price. Let us, for example, assume the price is 3. Then, if the price is 3, you can see in the demand schedule that the demanded quantity is 4. The supply schedule shows you that at a price of $3, the supplied quantity is 16. Since 16 is bigger than 4, the supplied quantity is greater than the demanded quantity. Or with other words, it is more produced for the market than consumers actually are willing to purchase. What happens? If supply is greater than demand, like here, the price will fall. If the price falls, it moves closer towards the equilibrium price of 2. This means if the price is greater than the equilibrium price, market forces will finally lower the price, and the price moves towards an equilibrium. What happens if the price is smaller than the equilibrium price? I chose the price of $1 here, which is smaller than the equilibrium price of $2. If the price is 1, the demand schedule shows us that the demanded quantity is 15. The supply schedule shows us that the supplied quantity is 6. 15 is greater than 6, therefore demand is greater than supply. People want to purchase more in this market than producers have produced for this market. What will happen? The price will increase. The price moves towards the equilibrium of 2. This means if the price is smaller than the equilibrium price, market forces will increase the price towards the equilibrium. In the previous slides, you saw that market forces will lower the market price when it is higher than the equilibrium price. You also learned that market forces will increase the market price when it is lower than the equilibrium price. In both cases, the market price moved towards the equilibrium. It seems reasonable to say that the price will always adapt to the equilibrium price. This is called the adaptation process. Adam Smith called it the invisible hand. When the adaptation process is finalized, the equilibrium price leads to the equilibrium quantity demanded and the equilibrium quantity supplied. Remember, these quantities are always the same. Consumers in the market purchase as much as producers produced. The price will stay as it is, so will the quantities demanded and supplied. This situation, when nothing changes, is called an equilibrium. In the following slides, I will present the adaptation process again, using a graphical approach. Note that there is nothing substantial new. It's just a different way to present the adaptation process. The demand and supply behavior of the market is represented by the demand curve and the supply curve, rather than the demand schedule and supply schedule in the example before. The market equilibrium is always located where the demand and the supply curve intersect. The price represented by this equilibrium is called the equilibrium price. You can find the equilibrium price when you move horizontally from the equilibrium towards the price axis. The equilibrium price is often marked with a star to show that it is the equilibrium price and not any other price. You learned that the equilibrium price leads to matching quantities demanded and supplied. Let us verify this statement. What is the demanded quantity which is associated with the equilibrium price? To find this quantity, we start at the equilibrium price at the vertical axis, at the price axis, and go horizontally until we hit the demand curve. Then we go straight down and find the quantity demanded. What is the quantity supplied which is associated with the equilibrium price? We use the same procedure. We start at the equilibrium price, move horizontally until we reach the supply curve, and we reach the supply curve in the same point where we reached the demand curve before, because it's an intersection point. So from the point where we reach the supply curve, we go down straight and find that we arrive at the same quantity supplied where we before arrived when we searched the quantity demanded. Therefore, demand equals supply if the price equals the equilibrium price. And that is actually what our definition says. If people want exactly the same amount in the market than it is produced, the price will not change. We will stay in this situation. Here's the procedure to find the equilibrium price and the equilibrium quantity in a nutshell. First, find the intersection point between demand and supply curve. Second, go horizontally to the left to the price axis and you will find the equilibrium price. And third, starting from the intersection point again, go straight down to the quantity axis and you find the equilibrium quantity. Because the equilibrium quantity is at the same time the equilibrium quantity demanded and supplied, it is labeled here X star rather than calling it D star or S star. Will the adaptation process, or you can call it the invisible hand if you like this better, will the adaptation process push the price back to the equilibrium if the actual price deviates from the equilibrium? We will test this first with a price lower than the equilibrium price. We call this price P1 to distinguish it from the equilibrium price. It is lower than the equilibrium price, and we start with finding the demanded quantity which goes with this price. We go horizontally until we reach the demand curve, go straight down until we reach the quantity axis, and mark it as D1, the quantity demanded which goes with the price P1. Which supplied quantity will go with this price? We start again at P1, go horizontally this time until we reach the supply curve, then we go straight down until we reach the quantity axis and mark the point with S1 showing this is the supplied quantity which goes with the price P1. D1 is further to the right than S1. The demanded quantity is greater than the supplied quantity. This means consumers are planning to buy more in this market than producers supplied. The price will increase, and this moves the price towards the equilibrium price. What if the price is higher than the equilibrium price? Will the adaptation process or the invisible hand push the price back to the equilibrium as well? A higher price would be above P star. We call it P2 to distinguish it from P star and from the lower price P1 we covered in the other slide. Which quantity demanded goes with P star? We go to the right from P star until we reach the demand curve. Then we go straight down until we reach the quantity axis and find the quantity demanded D2 which goes with the price P2. What is the quantity supplied which goes with the price P2? We start at P2, go horizontally to the right until we reach the supply curve. From there we go straight down until we reach the quantity axis and mark this point with S2 to show that this is the supplied quantity which goes with the price P2. You can see that now the demanded quantity is further to the left than the supplied quantity. Therefore, D2 is smaller than S2. The quantity demanded in the goods market is smaller than what producers have produced and supplied. The price will decrease and move closer to the equilibrium price P star. The market process or the invisible hand obviously works in both directions. If the price is higher than the equilibrium price, the invisible hand will push it down. If the price is lower than the equilibrium price, the invisible hand will push it up. This makes our life much easier, because if we know that we always end up in the equilibrium, we can just forget about the adaptation process. We know the system will always generate an equilibrium. Therefore, we ignore the adaptation process. If we want to analyze a market, we find the intersection point, then find the equilibrium price which goes with this intersection point by going straight to the left until we reach the price axis. Find the quantity, which is at the same time quantity supplied and quantity demanded, which goes with the equilibrium by going straight down from the equilibrium until we reach the quantity axis. What did you learn in this segment? You learned how the adaptation process always generates a market equilibrium. You learned that we can ignore the adaptation process and just trust that a market equilibrium will be reached when we analyze markets. You also learned how to identify a market equilibrium and how to identify the equilibrium price as well as the equilibrium quantity.